Hello, my name is Lokukaluge Prasad Perera. I am a professor from UIT, the Arctic University of Norway. So the title of my presentation is Advanced Data Analytics Based Hybrid Engine Propeller Combinator Diagram for Green Ship Operations. So the co-authors of these presentations are Kostas Belibassakis, Evangelos Filippas, and Maneesha Premasiri. This study is a part of a CTEC project, which is funded by the European Union under the Horizon 2020 Research and Innovation Program. So this is the outline of my presentation. First, I will give you a brief introduction, then the methodology, and then some concluding remarks. So there are various emission reduction rules and regulations being enforced. For example, the CO2 emission should be reduced at least by 40% by 2030 compared to the 2008 baseline, according to IMO legislations. So it is unlikely that the shipping industry will achieve these targets, including the 2050 emission reduction target, uh, only based on these existing vessel technologies. So there's a requirement new green ship technology should be developed, and then that should be retrofitted into the existing vessels. And at the initial stage, this can be done through the industrial digitalization, where these AI-based applications can be utilized. So then at least we can show in the initial level these emission reduction targets can be achieved. So to achieve the same objective, in this study, we propose this hybrid engine propeller combinator diagram. In one part, this is done in a theoretical level, and the other part, we are integrating the data sets from existing vessel. So therefore, these technologies integrating into the existing vessels and how their performance can be improved will be understood by this hybrid engine propeller combinator diagram. So this diagram is somewhat developed in a data science environment where we utilize various machine learning applications to create the AI. So then that could be a part of the industrial digitalization. So this data science environment will have three steps. First step, we considering the full scale data sets. And then the second step, we develop the seakeeping and ship performance curves. In the third step, we combine both of these data sets as well as these curves to create this hybrid engine propeller combinator diagram. So in the first step, we analyze this full-scale ship performance and navigation data sets. So we have a selected ship route for a selected vessel. And then the respective wind and wave conditions, these are the actual values, are downloaded from external sources with respect to the same vessel under the same ship routes. And from these data sets, we estimated the actual engine power requirement for these vessels to navigate through the same rate. That includes the respective fuel consumption also. And then that information we forwarded into the next step where we develop this seakeeping and ship performance curves in a more theoretical level. So before I move into the next step, I would say a little bit on this green technology integration. Under the CTEC project, we are proposing two innovative technology. So the first technology is the dual fuel marine engine with ultra high energy conversion efficiency to reduce the respective emissions. The second innovation is the biomimetic dynamic wing mounted on the ship bow to harvest energy from the wave fields. So in a way, this engine propeller combinator diagram can be developed for the dual fuel engine, but at the same time, we want to know how much energy efficiency will gain through this dynamic wing. So this is where this integration of engine and propulsion technologies are coming into a single picture. So this is where we develop this hybrid engine propeller combinator diagram. So as the next step, the seakeeping and ship performance curves are derived by considering the same selected vessel by utilizing its hull drawings. And this has been derived for two levels. One is this seakeeping and ship performance curve for the actual vessel operational conditions, and then the seakeeping and ship performance curves with the same vessel with the biomimetic dynamic wing. So that way, at some level, we can compare these curves to see the energy efficiency gain achieved through integrating these new innovations into the existing vessel. So you should also understand these situations can also be simulated, and this is where you can actually understand the performance gains coming from these CTech innovations. So as the next step, as the final step, um, we will develop the hybrid engine propeller combinator diagram by considering the sea keeping and ship performance curves. So these curves will be developed for two levels. One level is for the existing vessel. So that means without the biomimetic dynamic wing. So the next level is with the biomimetic dynamic wing. So here we are creating some type of a futuristic vessel based on the existing vessel. So therefore the dynamic wing technologies can be retrofitted into the existing vessel. So that was kind of main objective of doing this exercise. So then the data sets we collected from the same vessel will be overlaid into this engine propeller combinator diagram. So this case, this is the hybrid engine propeller combinator diagram for the existing vessel. So then these ship performance curves with and without biomimetic dynamic wing will be utilized to interpolate these data sets from the existing vessels to the futuristic vessel. So that way we're creating a data set for a futuristic vessel which has this dynamic wing. So an example of hybrid engine propeller combinator diagram is presented in this slide. As you can see in your left hand side, you can see the selected vessel without the dynamic wing. In your right hand side, you can see the same vessel with the dynamic wing. So this color bar represents the wave heights. So as you can see, due to high wave conditions, the vessel performance curves with the dynamic wing has a slight improvements in its power conditions. So as the next step, we plan to overlay these existing vessel datasets into this hybrid engine propeller combinator diagram and then interpolate these datasets by considering these ship performance curves. So that way, these data sets we can utilize to quantify ship performance, as well as we would be able to utilize towards to identify the emission reductions due to integrating green technologies such as this dynamic wing into these existing vessels. So finally, the conclusions. The approach we have described can be a part of the digital twin technology, because this hybrid engine propeller combinator diagram can be used as a basis for to develop a digital twin technologies for future vessels. So therefore, having such type of technologies can eventually support the respective emission control rules and regulations. One side it could utilize to integrate green ship technologies. Other side you can utilize to quantify the respective vessel performance. So in this study, we talk about the selected green technologies where you can utilize through a data science environment to reduce the respective emissions and to achieve the emission reduction targets. So the basis was this hybrid engine propeller combinator diagram we described that can be developed in the theoretical conditions, as well as it can be utilized by using the ship performance and navigation data sets. So eventually, the interpolated data sets can be utilized towards to create futuristic vessel conditions with having integrated new technologies. So these data sets can be utilized towards quantifying the performance of these existing vessels, not just only in the current conditions, but also by adopting or by retrofitting green technologies in the future to quantify their expected performance improvement. So thank you for your time. Any questions? And then we have these several social media links. You can always follow us for more information the progress of this study as well as the progress of this research project. Thank you.